Recent discoveries have revealed numerous strange and unusual phenomena occurring on Jupiter, many of which were previously unknown. The first infrared images captured by the James Webb Space Telescope have been analyzed, uncovering new structures within Jupiter's iconic Great Red Spot. This colossal storm, with winds reaching speeds of 270 to 425 miles per hour, 3.5 times faster than a powerful F4 tornado, is so vast it could engulf our entire planet. The Great Red Spot has been a massive, swirling storm for centuries, but recent observations suggest it is not as stable as once thought. It appears to be wobbling, almost shaking, and its size has been fluctuating in surprising ways. The storm, which once spanned over 24,000 miles, has now shrunk to about 10,000 miles. However, it's not simply shrinking steadily. Instead, it seems to expand and contract rhythmically, almost as if it's breathing. The reason for this behavior remains unclear. The wobbling motion is particularly intriguing and may be linked to the intense jet streams and turbulent swirls surrounding the storm. Jupiter's atmosphere is chaotic, and the energy from these dynamic forces could be influencing the storm's movements. Additionally, Jupiter generates significant internal heat, which might also be affecting the storm's behavior. Recently, there were moments when parts of the storm appeared to break off and drift away, leading some to speculate that the Great Red Spot might be disintegrating. However, given the immense energy fueling the storm, it is unlikely to vanish anytime soon. While it may change in shape or size, the Great Red Spot is expected to persist for decades, possibly even centuries. These recent changes serve as a reminder of how dynamic and unpredictable Jupiter truly is, and the new images from the James Webb Space Telescope are uncovering a wealth of mysteries about this gas giant. Citizen scientist Judy Schmidt from Modesto, California, processed some of the images of Jupiter using data from the James Webb Space Telescope, enhancing the original photos to reveal stunning details. The enhanced images clearly show auroras, a faint debris ring, and several of Jupiter's moons. The clarity of these images has allowed scientists to study Jupiter's atmospheric dynamics in unprecedented detail. Jupiter's upper atmosphere acts as a boundary between the planet's powerful magnetic field and the layers of atmosphere below. At the poles, spectacular auroras are fueled by volcanic material ejected from Io, one of Jupiter's moons. Near the equator, the atmosphere is shaped by sunlight, though Jupiter receives only about 4% of the sunlight that Earth does. This region was long assumed to be relatively uniform, but observations from the Webb telescope's near-infrared spectrograph in July 2022 revealed a surprising variety of features, including dark arcs and bright spots. The blue areas in the images represent lower altitudes, while the red areas indicate higher altitudes, suggesting a complex structure within the storm. One possible explanation for these features involves gravity waves, similar to ripples caused by waves crashing on a beach. These waves, originating deep in Jupiter's turbulent lower atmosphere, travel upward and influence the structure and emissions of the upper atmosphere. While similar waves are occasionally observed on Earth, they are far weaker than those on Jupiter. Another discovery was a previously unseen feature in Jupiter's atmosphere: a massive white band of clouds at the planet's equator, over 3,000 miles wide, moving at 320 miles per hour, far stronger than the most powerful storms on Earth. The James Webb Space Telescope is not the only tool providing incredible insights into Jupiter. The Juno probe, which traveled 1.7 billion miles to reach Jupiter, continues its mission, capturing stunning images during its 66th flyby of the gas giant. Using raw image data available to the public, citizen scientists have enhanced the contrast of visible light images, revealing Jupiter's remarkable range of colors and intricate atmospheric dynamics. These images showcase vivid bands, swirling cloud formations, and vortices, including cyclones and hurricanes of varying sizes and intensities. Some images even reveal interconnected cyclonic storms, suggesting that Jupiter's atmosphere is far more interconnected and complex than previously thought. Jupiter is not only a planet of mystery but also home to 79 moons, the largest of which is Ganymede, or Jupiter 3. In a Hubble Space Telescope image, Ganymede's immense size is evident. Orbiting about 666,000 miles from Jupiter, Ganymede is of particular interest for several reasons. The Juno probe recently captured new images of Ganymede, marking the first time in 20 years that the moon has been photographed in such detail. Analysis of these images revealed evidence suggesting that Ganymede may have been struck by an asteroid nearly 93 miles wide about 4 billion years ago, a collision 10 to 15 times larger than the Chicxulub meteor that struck Earth 66 million years ago. The impact was so powerful that it knocked Ganymede off its axis and altered its rotation. Interestingly, most of the material ejected from the collision fell back into the crater, leaving it mostly hidden. However, evidence of this massive impact can still be seen on the moon's surface, which is covered in craters, some of which are very large, indicating that Ganymede has been hit by multiple massive asteroids in its history. Ganymede may also harbor other secrets. Recently, water vapor was detected in its thin atmosphere, located 500 million miles from the sun. The water ice on its surface is frozen solid at temperatures as low as -300 degrees Fahrenheit, making the surface as hard as rock. However, charged particles from the sun can still turn the ice into water vapor. While Ganymede may appear to be a barren ice ball, some scientists believe that beneath its icy crust lies a vast ocean of liquid water, which could potentially harbor life or provide clues about the conditions necessary for life to emerge. New missions are planned to explore this possibility. Another fascinating moon of Jupiter is Io, which is far from a quiet orbiter. Io is covered in lava lakes and over 400 active volcanoes that constantly spew volcanic material into Jupiter's magnetosphere. The Juno probe captured images of 2 volcanic plumes erupting on Io, and recent data revealed a massive volcano erupting. Combining data from Juno's instruments, scientists discovered that Jupiter produces bursts of X-rays every 27 minutes. This phenomenon is linked to Jupiter's rotation, which drags its magnetic field around, compressing it and heating the charged particles trapped within. This process generates electromagnetic ion cyclotron waves, which guide ions to Jupiter's poles, triggering the incredible X-ray auroras observed in images. Io's orbit, 262,000 miles from Jupiter, cuts across the planet's powerful magnetic lines of force, turning the moon into an electric generator capable of producing 400,000 volts and creating an electric current of 3 million amps. This current travels along Jupiter's magnetic field lines to the planet's surface, creating lightning and auroras in Jupiter's upper atmosphere. Decades of study have revealed just how intricate Jupiter's system is, and recently, 12 more moons were discovered orbiting the gas giant, bringing the total number of known moons to 92, more than any other planet in the solar system. The newly discovered moons range in size from 1 to 3.2 kilometers, with most having extensive orbits that take over 550 days to complete one revolution around Jupiter. Scientists believe these distant moons, which move in the opposite direction of Jupiter's rotation, could be captured asteroids. Jupiter has long been thought to act as a protective shield for Earth, deflecting comets and asteroids that might otherwise collide with our planet. However, recent findings challenge this view. While Jupiter's gravity does fling many long-period comets away from the solar system, it can also redirect asteroids toward Earth. For example, in 1770, Lexell's comet passed within 1 million miles of Earth after a close encounter with Jupiter altered its trajectory. While Jupiter's gravity can protect Earth from some threats, it can also increase the risk of collisions with other objects. Jupiter's role in the solar system is complex, and its immense gravity influences the asteroid belt, causing some asteroids to deviate toward the Sun and potentially collide with Earth. The frequency of such impacts plays a crucial role in the evolution of life on a planet. Earth's geological record shows that major collisions occur roughly every 100 million years, allowing the biosphere time to recover. However, more frequent impacts could devastate the planet, hindering the development of life. Some scientists believe that water on Earth may have been delivered by comets and asteroids, and recent discoveries suggest that Jupiter also contains significant amounts of water. Water vapor was first detected on Jupiter in 1995 by the Galileo spacecraft, and recent data from the Juno probe has revealed even more evidence of water in the planet's atmosphere, particularly within the Great Red Spot. Jupiter's atmosphere is also home to mesmerizing lightning displays, 100 times brighter than those on Earth, and peculiar hailstones. Lightning has been detected in Jupiter's water clouds, where water droplets collide with electrically charged ice crystals. However, the Juno probe has also observed dim lightning at higher altitudes, where temperatures are too cold for liquid water to exist. The mystery of how lightning occurs under such conditions may be explained by ammonia, which acts as a natural antifreeze in Jupiter's upper atmosphere. Water ammonia droplets collide with ice crystals, generating electrical charges that produce lightning. These droplets can grow into large hailstones that descend deeper into Jupiter's atmosphere. Delving deeper into Jupiter's interior, scientists have discovered that the planet's core is not as compact as once thought. Under extreme pressures and temperatures as high as 20,000 degrees Celsius, Jupiter's core is composed of about 18% rocky material, with the rest being predominantly hydrogen, 90%, and helium, 10%. As one descends into Jupiter's atmosphere, hydrogen transitions from a gas to a dense, metallic fluid that conducts electricity. This liquid metallic hydrogen, found about 10% of the way toward Jupiter's core, is a unique substance that behaves like a metal, conducting heat and electricity efficiently. This layer, combined with Jupiter's rapid rotation, generates the planet's colossal magnetic field, the largest in the solar system. Jupiter's magnetic field is far more complex than Earth's, with a great blue spot near the equator acting as a second south pole. This region experiences fluctuations in magnetic field strength, and scientists are still studying its connection to the Great Red Spot. Jupiter's atmosphere also features a great cold spot, a region about 200 degrees Celsius cooler than its surroundings, which is linked to the planet's auroras. These auroras, fueled by charged particles from the Sun and Jupiter's moons, transfer energy to the atmosphere, creating temperature differences that form swirling vortices. Interestingly, Jupiter does not orbit the Sun in the traditional sense. Instead, both Jupiter and the Sun orbit a shared center of mass, known as the barycenter, located just above the Sun's surface. This is due to Jupiter's immense size, which is 2.5 times the mass of all other planets in the solar system combined. Jupiter's volume is 1,300 times that of Earth, making it a dominant force in our solar system. Recent observations suggest that something unusual is happening on Jupiter. The Great Red Spot, which has been shrinking and changing shape, may be influenced by interactions with smaller storms. As anticyclones merge or collide with cyclones, they can either combine or scatter, leading to the detachment of large chunks from the Great Red Spot. While the storm is still active, with wind speeds increasing by 8% from 2009 to 2020, it continues to shrink and may disappear within the next 20 years. What this means for Jupiter and its atmosphere remains uncertain, but it highlights the dynamic and ever-changing nature of this gas giant. Jupiter continues to be a focus of scientific study, with missions like Juno and telescopes like Hubble and Webb providing new insights into its complex atmosphere, magnetic field, and moons. As we learn more about Jupiter, we gain a deeper understanding of the solar system and the forces that shape our cosmic neighborhood. The mysteries of Jupiter are far from solved, and each new discovery brings us closer to unraveling the secrets of this colossal planet.